Welcome to Catalyst Grid. My name is Kingsley Amofua, lead scheduler with DC Nordics. Today we take on one of the most physically demanding phases of Series 3. We are deep into Series 3, building the machine. We've surveyed the unknowns and secured the power, but now we are literally breaking ground next to a live heart. Episode 5, Building the New Data Halls, adjacent to live. This is where the theory of brownfield management meets the heavy reality of steel and concrete. The challenge is simple to state, but complex to execute. We are doubling the facility's capacity while the existing 15 megawatts of load continues to hum right next door. Our objective is the construction of DH New C and DH New D. But in brownfield, construction isn't just about building up, it's about containing the impact of every move we make. We have 800 active tenant racks. Each one represents an SLA, a contract, and a business that cannot tolerate a single second of interruption or environmental contamination. Isolation begins here, at the construction boundary. This isn't just a fence, it's a multi-layered, fire-rated, acoustically dampened barrier. We build these partitions to a specific fire rating and sealing standard. They must isolate the dust, noise, and heat of construction from the critical cooling air of the halls. Acoustic dampening is vital. High-frequency noise from construction can actually interfere with hard drive performance in the live halls, so we aim for an STC rating of 50 or higher. But the biggest threat is dust. Construction dust is often conductive or abrasive. If it enters a server intake, it can cause short circuits or mechanical wear. To manage this, we implement a negative pressure protocol using industrial heaper units to pull air away from the live halls. We maintain negative pressure in the construction zone. This ensures that any time a door is opened, air flows into the dirty area, never out into the clean data hall. We monitor the pressure differential constantly. Our target is a steady 5 pascals. If that pressure drops, alarms trigger an immediate halt to all dust-generating work. Our cleaning protocol is exhaustive. Every surface is wet misted to trap dust, followed by HEPA vacuuming. There is no dry sweeping allowed on Project Vertex. Transition zones are established at every entry point. Sticky mats and airlocks ensure that no site debris is tracked into the critical corridors of the facility. Moving to the mechanical threat, vibration. Large excavators and piling rigs send tremors through the slab that can be catastrophic for sensitive IT equipment. We operate under a strict limit of 0.5 millimeters per second peak particle velocity. This is far below typical construction limits, but essential for maintaining disk drive integrity. We use continuous flight auger, or CFA, piling. By drilling instead of driving, we virtually eliminate the high-impact shocks that traditional piling would send through the existing slab. Even with CFA piling, we schedule any significant groundwork during low-utilization maintenance windows, typically between 1 a.m. and 5 a.m. when the risk of operational impact is lowest. All stationary plant equipment in the construction zone is mounted on vibration dampening mats. We are decoupling the project's vibration from the building's structural frame. Then there's the invisible threat, EMI and ESD. In a high-density environment, a single static spark or an unshielded motor can disrupt communications. Welding is strictly controlled. We use shielded curtains and grounding protocols to ensure that electromagnetic fields don't bleed into the data hall's network cabling. Humidity is our ally against static. We maintain a relative humidity of 45 to 55%. Too dry and static risks skyrocket. Too damp and we risk condensation on cold aisles. With these protections live, we can build. The steel framing for DH New C and DH New D is designed for rapid assembly. We use bolting instead of welding wherever possible to reduce heat and EMI. The tie-ins to the existing building are designed to be non-load bearing for the first 12 months. This allows the new structure to settle independently of the live facility, preventing structural stress. Fire compartmentation is sacred. Every time we breach an existing wall for a tie-in, temporary fire stopping must be installed and signed off by building control before the shift ends. All of this is managed through the tenant impact register. Every activity, piling, steel lifts, wall breaches, is logged, risk assessed, and communicated to the 800 tenants well in advance. Our schedule isn't just a list of dates, it's a promise of stability. In a brownfield environment, project controls are about managing operational risk as much as construction progress. This brings us to the brownfield signal. Today's critical interface is the slab-on-grade pour. We are pouring thousands of tons of concrete right next to the existing footings. During the pour, we monitor the existing facility for any sign of settlement or slab heave. The weight of the new concrete can shift the soil under the live building, a risk we mitigate with phased pouring. Managing these risks requires a collaborative culture. That's where the NEC4 Option C contract shines, incentivizing both contractor and owner to solve these technical challenges together. We are at month 16. The shells of our new data halls are rising, the live load is secure, and we are on track for the most complex part of the project yet. Building adjacent to live IT requires a mindset of containment. We protect the core so we can grow the capacity. In the next episode, we reach the technical peak of the series, MEP tie-ins. We will connect the new halls to the existing chilled water and power systems. Kingsley Imufua, your host, signing off. Do not forget to subscribe, like, share, and comment. See you at the tie-in. To ensure we hit our 10-minute target, let's dive deeper into the engineering of our temporary boundaries. This partition isn't just about dust, it's our primary fire defense during construction. We specify intumescent materials that expand when exposed to heat, sealing the air gap between the construction zone and the live hall. This buys the team critical minutes in an emergency. We even analyze the resonant frequency of the construction tools. Hard drives are surprisingly sensitive to specific sound frequencies, and we ensure our boundary dampens those exact waves. Our HEPA units aren't set and forget. We rotate pre-filters every 24 hours. If the pre-filter clogs, the motor strains, EMI spikes, and airflow drops, triggering a maintenance alarm. Seismic sensors are placed strategically. We don't just monitor the site boundary, we monitor the actual rack frames of our most sensitive tenants. Their uptime is our scoreboard. Before we pile, we verify. Ground penetrating radar, or GPR, is used daily to ensure the as-built reality matches our 3D model. One misplaced pile could sever a live fiber uplink. CFA piling allows for extreme precision. We monitor the torque and depth in real time, ensuring we don't hit unexpected subterranean structures that could transmit vibration to the hall. Settlement monitoring is constant. We use automated total stations that bounce lasers off prisms mounted to the existing columns every 15 minutes to track any movement. We test our EMI shielding effectiveness. A 40 decibel reduction in electromagnetic noise is our baseline for any high-energy work near the communication rooms. Even the new halls are designed with ESD protection from day one. We install conductive flooring systems to ensure that static never becomes a problem as we move toward handover. Take a look at this tie-in. Every cable collar is color-coded. If a seal isn't perfectly flush, it's rejected. Building control doesn't accept good enough in a brownfield environment. The communication loop is where the project lives or dies. Every morning, the site team and the data center ops team meet to sync their schedules. If a tenant has a high-risk migration, we pause construction. The tenant impact register isn't a passive document. It's a live risk management tool. We assign a mitigation owner to every activity that has a non-zero impact on the halls. Back to the piling. Torque monitoring tells us exactly when we hit different soil layers. This allows us to adjust our speed to maintain that 0.5 mm vibration limit. Why bolting? Besides EMI, welding requires firewatches and creates fumes that our HEPA units have to work harder to scrub. Bolting is cleaner, safer, and faster for brownfield tie-ins. When the auger comes out, we pressure grout the pile immediately. This prevents the soil around the existing foundations from shifting into the new void, maintaining structural stability. Before the final tie-in steel is fabricated, we laser scan the existing columns. We don't rely on 2012 drawings. We build to the 1 mm reality of the current structure. We perform airtightness tests on our boundaries. If smoke doesn't pull cleanly toward the construction zone, we know there's a seal leak that needs intumescent caulking. The construction zone has its own wireless fire alarm system linked to the main facility. If a fire starts on site, the live halls know about it instantly and the suppressions are ready. Look at this comparison. Traditional piling would have been a non-starter here. The CFA method is what allows us to sleep at night while the rigs are running just 10 meters from the racks. Tenant briefings are about trust. We show them the real-time vibration and dust data. When they see the engineering rigor behind Project Vertex, their anxiety about the expansion disappears. Even the best plans face unknowns. When we find an undocumented service, the NEC4 contract's compensation event process allows us to address the cost and schedule impact collaboratively without litigation. The telemetry from our rigs is fed directly into our 3D model. We are creating an as-built record of every pile, centimeter by centimeter, for the facility's future. Our load path analysis ensures that the vibration from new slabs doesn't create harmonic resonance in the old building. It's advanced structural physics applied to construction management. Why pillows? Because we need to re-enter these penetrations daily as we pull new cables. Intumescent pillows provide a 2-hour fire rating while remaining fully re-enterable for the team. Even the soil removal is controlled. We use sealed skips to ensure that dry earth isn't blown back toward the facility's fresh air intakes by the wind. Every detail matters. This is the Vertex standard. We don't just build, we engineer the environment around the build. This 10-minute deep dive shows only a fraction of the work that goes into protecting the live load. To recap, isolate the boundary, scrub the air, dampen the tremors, shield the signals, and always keep your tenants informed. That is how you build adjacent to live IT. We have reached month 18 of the 32-month program. The physical shell of the expansion is complete, and the existing halls are humming along perfectly. Phase 1 is a success. Next time, we open the valves. Episode 6 is the MEP tie-in. We will connect our new capacity to the live cooling loop. It's the highest stakes moment of the series. Join us. My name is Kingsley Amafua, your host. Thank you for being part of the Catalyst Grid journey. Do not forget to subscribe, like, share, and comment. One love, brother. Silence with a low, industrial ambient hum. This is Building the Machine, Series 3, Project Vertex, Expansion in Progress.